Hey everybody, what's up? How's it going? We got 2 problems today. I already finished them. I think it was Friday, and today we're gonna go through them and see what I did wrong. And I most likely did something wrong. Sebastian will not be joining us. That's my cat. He is currently taking a nap. All right. Zoom in. Number 79, it says, which of the following seismic design statements are true? The seismic base shear of a building increases as the building dead load increases. So I said yes to this one, and I did that because the base shear is equal to CS times W, and W is the weight of the structure. So I said this one was good. In areas of high seismic activity, it is best to design buildings with an irregular floor plan to better break up the seismic load. So I said no to this. Because according to, if you're following ASCE, this is a bad thing. You get penalized for this. So that's why I said this one doesn't sound true. Third statement, according to ASCE 7, flat roof snow loads under 30 pounds per square foot need not be included in the effective seismic weight of the structure W. So I don't think I ever checked this one, but we'll see in the solution. I said that that was true. Not quite sure. And the fifth statement, buildings with a soft first story and heavy roofs performed well during Northridge in 1994. So this one obviously is not true. Soft stories are when you've got a pretty weak first story and a pretty rigid second or third story. And all the mass is up here. So typically these were made in situations where you wanted like a garage in the first floor. That's a car. And so these weaker first floors were shaking a lot, and these top ones weren't. And so all the buildings in this area were just toppling over and crushing the first floor. And a lot of the design codes were actually changed because of the Northridge earthquake and the soft story effect. So that one's not true. Sometimes they get me because sometimes they say are not true, and I don't read the problem statement. It becomes a problem for me. Oh, okay, I didn't read this either. Hint, chapter 16 of the IBC provides information on seismic design. I mean, I was going off of ASCE, but yeah, whatever. All right. So solution to number 79 is B. And that's what I said. So let's see their reasoning. So these sections are probably old, but they confirm what I said on W. ASCE 7 states that where the flat snow load exceeds 30 psf, the effective seismic weight shall include 20% of the uniform design load. Statement 3 is also true. Okay, I'm going to try to remember that. The flat snow load exceeds 30 psf. 30. Okay. So I already knew this one right here. already knew this one. I already knew this one. I did not know this one. So the major takeaway, I'm going to write it here, is that if, I think it's called PF for flat snow load, is greater than 30, PSF include 20% in seismic weight. All right. Got that one correct. I don't think I got this one correct. Okay, so the problem statement. A 2-story office building located in South Dakota, it's an office park, is 40 by 60 feet in plan. The asphalt shingle hip roof has a 6 to 12 pitch and is supported by rafters spanning the short direction of the building. The attic is vented and insulated with R30 insulation. The local building code official requires design using IBC. IBC is essentially ACE, so I just skipped straight to ACE. If the ground snow load is 40 pounds per square foot, what is most nearly the maximum leeward snow load? Okay, so I didn't look at this word. I feel like that's important. And I didn't read the hint either. The leeward side of the roof, okay, obviously. The leeward side of the roof is the side away from the wind. Don't know that? You should know that now. Memorize that. It's not that hard though, because the opposite is the windward side, so it's kind of in the name. All right, let's see where I messed up. It's probably this windward versus leeward thing. Wait, what problem? 23. Oh my God, 23. Cool. All right. So we got this part right. Flat roof snow load is this junk. The snow exposure category CE. CE is 1. What did we say? So we got this one wrong. The roof exposure category for suburban location can be assumed to be partially exposed. Based on these factors, CE is 1. What does that mean? All right, let's take a look at ACE and see why we got that wrong. Maybe it's because I'm using ASE instead of IBC. Chapter 7. Okay. Table 7.3-1. Okay, I think I said it was Surface roughness of category B. Yeah, so it's B. And then they said it's partially exposed. I was saying that it's fully exposed. Whatever. I guess it's partially exposed. Okay. Roof exposure category. Partially exposed. How are you supposed to tell? All roofs except as indicated in the following text. That's helpful. Roofs fully exposed. Roofs exposed on all sides with no shelter. B. What is B? Where are the footnotes? Give me the footnotes. All right. Oh, it's the same thing. Obstructions within a distance of 10 H0 provided shelter where H0 is the height. So, I don't know. To me, it's not partially exposed. A terrain. I guess we'll just have to say key point here is make this red. All right, key point. Suburban equals partially exposed. Exposed. All right. Let's see if we got CT correct. CT. The thermal factor CT is given in ASE 7 table 7.3. 1.1 for ventilated attics with insulation greater than R25. Yeah, I mean, we essentially got that correct. Where did the 1-3 come from for me? Oh, I was using the wrong table. That's what it was. What table was I using? I remember seeing it. It was like a table that it had like the R factors in there, the ventilation factors. CT, table 373-2. What was I using? Okay. Well, I definitely did that wrong. Structures kept just above freezing, and others with cold ventilated roofs in which the thermal resistance R value exceeds 25, so we had an R value of 30. So I got that wrong. Wrong table. Wrong exposure. All right. 2 for 3. Let's see what CS is. All right, CS table 74-1. Warm roofs, cold roofs. Okay, so we're cold roof. I think we were 6 on 12. Six on 12. Oh, what's the dashed line? Anybody know what the dashed line is? Say it's 1. Let's see what they say. CT, thermal factor, CT. We're looking for C. Wait, did I use the wrong equation too? So they have 0.7 CE, CT, I, PG. CTC. Where's the CS? Okay, office buildings are category 2. I think in the new ASCE for snow, they don't use importance category or importance factors anymore, so ignore that. So they get 30.8 for PF. I didn't check the minimum. Okay, here. They explain what the solid line. So for cold roofs, found in the CT of 1.1 graph, CS is determined from 7.2b using the solid line for asphalt shingle roof. I think that's the difference. I think all other surfaces is like asphalt shingle roofs, and then unobstructed slippery surfaces, as vague as that sounds, just means non-asphalt shingle roof, I guess. And then, so I think takeaway number 2 is use the correct table. Third thing I did wrong was I didn't check the minimum. Let's see. Does ASCE have the minimum here? Minimum snow load for low slope roofs. Okay. Where PG exceeds 20 pounds per square foot. Okay, so the importance factor for category 2 versus category 2 is just 1. So the minimum should just be 20 PSF. Is that what they did? Okay. Minimum is 20 PSF. And they multiply by CS, which is 1. And then okay, this last part I also did not do. To determine the maximum snow load, the unbalanced condition must also be considered as found in ASCE 7 section 7.6. W is the horizontal eave to ridge distance, or 20 feet, according to ASCE 7.6.1. W is 20 feet or less. The unbalanced snow load on the leeward side is blank. I don't know about that. 40. Unbalanced. What does that mean? Is it snow load? Partial loading? No. Yeah, I don't know what they're talking about. Minimum. So we've got the minimum. We've got sloped roof snow loads. Warm roof, cold roof. Oh, okay. It's the same chapter. Unbalanced roof snow loads. Hip and gable roofs. I think this is a hip and gable roof. This is a lot for a 6-minute question. Hip roof. For a hip roof with a slope exceeding 7 on 12 or a slope less than half on 12. Okay. Roofs with an eave to ridge distance W of 20 feet or less. Is that what we have? 20 feet. Are not required to be applied. Wait, oh. Simply supported prismatic members spanning ridge to eave shall be designed to resist the unbalanced uniform snow load on the leeward side equal to IPG for these roofs. The windward shall be unloaded. Okay. So our PG is 40, our I is 1, so it just becomes 40 on the leeward side. It becomes option C. Boom. All right. I got that one wrong. That is the end of this set. I think we got like one problem correct. So we got that one right. Or sorry, wrong. We got this one right. This one from a few days ago, I got it correct, but I did it wrong. So I'm gonna say ultimately that's a 0. So I got 1 out of 3. This one for sure I did wrong. So that's a 1 out of 4. And this one I did wrong. So, final thoughts. Final score. 1 out of 5. Right? 1, 2, 3, 4, 5. 1 out of 5. Wonderful. 20%. Well, we're starting off on a high note with studying for the SE. I'm going to make a new set, probably from the same source. But this source is all sorts of different types of questions. Everything structural, focusing on the depth for PE problems. Work my way up towards SE problems. I've got some SE material already. And I think when I actually start getting good scores on the PE stuff, then we can move to the SE. But so far, I don't see a huge benefit or really a huge urge to move towards the SE stuff, especially because they're changing the format of the SE. It's going from paper to online based. So they're going to come out with some new material. I think NCES is going to come out with some new practice sets, practice problems. And when they do, after they've gone through their first round of it, they'll put it out, and I'll probably purchase it and do some practice problems on this stream. So yeah, if you're looking forward to that, if you're looking forward to the PE, if you're a structural engineer and you're studying for your California PE, let me know. I can help you out with some resources and let you know which books were good to use for the PE itself. You can't go wrong with anything from PPI, NCES, all those stuff. Those practice problems are great. I'm personally right now, the ones that I'm showing are not from PPI or from NCES, but they're still pretty good. I like them. So yeah, if you have any questions, if there's anything that you want to talk to me about, or if you want to tease me about the problems I got wrong, let me know, or just comment on this video. I'm sure I'll have it up on my channel later. So thanks for watching. If you watch this later, check out the rest of my videos, subscribe, and I'll see you next time. All right, bye.